Hello, my name is Mark Ericksen. Thank you for the introduction. I work at Fly.io, and I do host the Thinking Elixir podcast. And today we're going to talk about going global with a normal Phoenix app. And so first we kind of have to define what is normal. What do we mean by that? And so what I mean by that is I'm talking I've got my Postgres database. The app that I'm trying to do this with was not designed and from the beginning to be global. It was not designed to be be distributed. And it's probably a monolith. This isn't microservices with an architecture of a bus communicating everything. And this is something that I just created with my mix Phoenix new command. And that's the starting point that we want to go from. So let's talk about how people do it today. How do they solve that problem? So if you think about it, that's usually when we're talking web apps, it's with a SPA, like a single page application. So your back end, we've got a Phoenix app, it's got our business logic, and I might have my REST controller, maybe I'm using GraphQL. For this purpose, it doesn't really matter, that's not relevant. But then I got my front end, and my front end I've got a React, maybe it's Vue, and then I've got a lot of logic that I've ended up putting into my front end. And I've actually got storage, the caching the data that's in my front end. And I'm having to send the data back and forth from the front, and so I've got to serialize that. But that's the solution that we're doing right now, and it has some pros and cons. The pro is this gives a really fast, responsive experience to the user, right? Because the front end is running in their browser, it's you can't get closer than that, right? That is fast. Some of the cons, and another pro is that devs are familiar with this, right? It is a familiar stack. This is what everyone's doing. You can stick that SPA front-end stack on an Elixir backend, a Rails backend, a PHP Laravel backend. Kind of doesn't really matter, because at that point, it's not really about the backend. You're not really leveraging anything special about the backend, which means we have all this awesome Elixir that we're just not fully utilizing. And so we also got to consider that in order to make it snappy, we need to cache data on the front end. We need to send data down, serialize it, but we're not sending all the data, so we have to package it up. Maybe it's a subset of the data, maybe we're even pre-processing some of it, and we're sending it down. And then we have to store it so we can have navigation around in the front end and have it be really super snappy because all the data is already there. And then we have the problem, say I want to delete something. When I delete it, I want it to be super snappy, so I'm going to make it immediately disappear from my list in my front-end JavaScript. And then I'll send the request to the server, say, oh, please delete this thing. And that's great, but then what if there was a business rule that says, oh, you can't actually delete that? Right? So then, that ends up meaning I need to end up pulling more business logic into my front end so I don't have those embarrassing problems where I have to try and recover from. So now I'm duplicating a lot of business logic. It's that's just not ideal. And as far as the teams, right, we think about the teams who are developing this application. Oftentimes we'll have a separate UI team who's owning the front end. And it's probably a separate code base, probably versioned separately, and it's deployed separately. We have to coordinate our deploys when we deploy the back end and the front end, which goes first, and make sure it's going to be graceful rollouts. So there's a lot more planning that we have to do. So this isn't exactly what we're talking about going global with, because this is what people are currently doing. But what can we learn from this approach? So one of the things we learn is that people say, wow, this whole problem of having my server far away in Virginia gives a bad experience when I have a 1 megabyte JavaScript payload to deliver, to load my app, so I'm going to put it in a CDN. So if I can put it in CDN, then I can get it closer to my users over in Australia and the users over in France, and they get the payload fast so they can get the app started up quickly, and all the assets that we're going to be loading are close. So they get a better experience. So let's just break this down a little bit into the layers that's happening here. So like the top layer, that's our database. All the way at the bottom, we would have our user. So through the Phoenix portion of the app, we've got our business logic. We've got routers that are working on the server. We've got controllers or GraphQL resolvers. And then we're handling serialization. And that's where we have the big break where we have long distance from our backend server to where our user is. So now we've serialized our data, so now we're in the front end. It's running in the browser. We're deserializing. We have to store that data somewhere. Now we have to have some business logic just to make sure that we're not having a bad experience of creating something and then saying, oh, sorry, I can't actually do that. And then you're also having JS routers so they can navigate around. And then you have your UI components. So it's a lot of complexity there. But it has the pro of being super snappy and responsive. But this is the live view version, right? And you see, like, that's just so much simpler. And then you start to understand when you look at this and you think about it, it's like, wow, I've got my business logic, my routers, my UI components, and my live view page that pulls it all together. And you realize that's why people are so excited about live view. That's why, like, last year or the year before was ElixirConf, right? Where every presentation was about live view. Because, like, people are, like, excited by this. But how does this handle distances? That was one of the big complaints that people had about, or concerns that people had about live view, is that, you still got these far away distances. It's still going to give a bad experience if you get really far away. So that's what we're talking about, is how do I solve that problem and be able to take this live view app that I'm excited about? How do I do that? So first, let's talk about the distances. Like, I'm talking about something, from the West Coast to Europe. You can even go further than that. We could go to, the Philippines or something. But, like, this is the distance we're going to be talking about for today. So let's take a quick look at this. Let's see. All right, so here I'm connected up to Paris. This is actually talking to a server running in Paris, and there's my ping time. So you can see, and that's also the conference Wi-Fi, so that's not bad, right? I was actually, like, really afraid of the conference Wi-Fi, so. So far we're doing good, right? So this is actually talking to Paris. Like, okay, so what does a live view experience feel like when I'm talking to a server really far away? This is really helpful when I think about just switching it around, right? If my app is running here in my backyard and I want to know what it's like for my users in Paris, this is what it's like for them, right? It's the distance, it's the back and forth. Doesn't matter which side you start from, we're covering that distance as a round trip. So this is a live view app. So as I navigate around, these are live redirects, so there's a little bit of a delay, right? But it's not bad. And I can click things out, and, it's not bad, right? It's like, that's okay. But, if you go further, then it becomes even a little bit more pronounced, like geographically further. But that's what it looks like and feels like. That's what we're talking about. So when you compare these two architectures, you start to understand why people are excited about live view. And you say, man, I want these benefits too. I want to do that. But what we just saw, we didn't solve the long distance problem yet. We saw that it's actually not that terrible, but it's not SPA friendly, right? It's not, like, super responsive. But I really want to cut out all those layers. And, the main reason is because I don't want to have to create, deploy, maintain all these different layers that have the team have to maintain all that code. It's a lot more to do. It means to deliver a feature, that feature has to be plumbed all the way through that stack. And I really want to get the benefits of this time distance, so how do we do that? All right, so one of the things that we come back to what we learned from the single page application approach is we're using a CDN to get close to our users, and they're caching the data, a replica of it, that data close to the user so they can have that fast navigation, jump around, have a good experience. So that feels good. Like, what can we do with that? Well, what if we could actually take our app and deploy it like a CDN? So that would mean I deploy my app in the locations where my users are, like close to them. It's like, wow, that would really shorten the distance, right? But then if you look at this diagram, you're like, wow, that means I've got 3 separate databases for 3 regions, and how am I gonna manage migrations, and are they forked? You know, it's a mess. Like, I don't want to deal with that. So it creates a problem for changing data. So we don't want to have disconnected databases. So thankfully, Postgres supports replication. And so in this diagram, blue is our primary database, primary Postgres database, and the red represents our replicas. And Fly.io makes this super easy to create a replica. And just you create a primary, and then you say, I'd like to have another one over here, so you create a disk area for it, and you scale it out, and you now have it. It automatically sets up the replica, and it's configured. So now I have a database, a full cache of my database close to my users. But it's read-only. So I still have that problem. I can't make changes. So we'll come back to that. But first, how does it feel when it's close, like physically close? So let's take a look at that. So let's switch over here. There's a feature in Fly where you can pass a different header and where you can request what region you want it to send you to. So Dallas-Fort Worth happens to be pretty close to where we are. So if I just turned it off, this is where it would go. And that's conference Wi-Fi. You know, like you can see why they say conference Wi-Fi is rough, just because it's like the ping times are all over. But it's actually still pretty good. All right, so let's see, how does this actually feel? It's like, the test here is we're talking about read-only, so how does it feel for navigating around? Like, you know, everything's just kind of popping up, navigates really fast. I can just, you know, it's super responsive, and you're like, it's like no big deal. Like, that's what live view is like for me when I'm running on my desktop, right? That's normal. Okay, but we haven't solved how to make changes yet. So how do we make database modifications? Unless you're making a blog, right, then you want to do something. You want to make changes. So we created a library called Fly Postgres. It's available on HexPM. It's an Elixir library. It works really well on Fly. It works really well for local development. And it intentionally does not lock you into Fly, right? The goal is not to be like, oh, if you adapt your application to use this, you are tied in. It's like, no, we don't. It's not about that. We don't want to do that. In order to be useful, though, you do have to have multiple regions. Your application needs to be clustered across those regions, and you need to have primary and read replica Postgres databases. So that happens to be really easy to do on Fly. But if you can set that up somewhere else, you can make this library work for you too. So the other important thing is it's easy to add this to your application and easy to rip it out if you're wanted to. It's like the whole idea is to be as least impact on your business logic and code. So, you know, the goal is do not rewrite your app. So if you have your existing repo code, like, you know, code that says repo.insert with a change set, repo.update with a change set or a delete, that code doesn't change. When we put the library in and we configure it, what we're doing is the library will proxy those calls over to the primary region, which happens to be Paris, and do the database updates there. and my business logic doesn't change. And all of my read operations, my selects, my gets, my joins, all of that stuff is already local on my replica, so it's already super fast. So let's get an idea, let's get a feel for that. Like, what does that look like when I'm doing this? So if I'm over here and I want to create a new thing, so this is, remember, let's just get a reminder, right? We're talking to Dallas, but Dallas is read-only, right? All the writes have to happen in Paris. So when I go and make a change, like I have a location here, I'm going to edit it. When I make a change, it just like happened. And that was cool. And can I delete it? Yeah, it just happens. That's cool. And I can create a new one. So how is that working, right? That's what we're going to talk about, and then it's more complexity that we want to address too. One other thing I do want to show is, like, here's where you start to feel it a little bit. Like in this one, every time, like I'm customizing the avatar, right? Every time I click like a profile color, it changes immediately with the click, right? So you can start to see a little bit of a lag, like click, click, a little bit of a lag. Like you start to see a little bit of a lag on updates because they have to go so far. But like that's without me making any code changes, right? I'm not like doing optimistic stuff. I could, if it was really important, I could make optimistic stuff to apply that change to the live view and then send the database record off. But it's like that's without me making any changes. So I consider that a win. So how does this work? Let's dig in a little bit to understand it. So we wrap your repo. So you take your normal repo and like you can change the name of it. You put a like .local on the end of it, and all that's doing is kind of moving it out of the way. And then at the bottom, we're going to add a new repo that has the same name as your current repo, and that uses fly repo. And we tell it, here is my local repo, which is actually connected up to my read replica that's local. So it manages the proxying. So it says if it's a read-only database operation, I'm just going to apply that to the local database. If it's a modifying method function, it's going to proxy that over to Paris and wrap it all up for me. So first, we have to know, like, well, how do I know where to send those requests? How do I know where my primary is? Because it's going to be different for everyone's application. So when you create a new app on Fly and you launch it, it creates a fly.toml file. And in there, you can set environment variables. And you just tell it, my primary region is CDG, which is the 3-letter airport code for Paris. And so that's how Fly names they have a list of all their regions, and they each have little codes. And that's it. That's how we identify what our primary one is. So we also have another library called FlyRPC. And this makes it really easy to do RPC, or remote procedure calls. And this is also on HexPM. So this is used to, you add this to the application, and when you deploy your app in multiple places, and you have clustering enabled, then the apps just kind of talk to each other and say, hey, I'm in this region, and oh, I'm in this region. And they coordinate to share that information with each other. So when you writing your code, you say, I want to run this in the primary region, it knows where that is and how and which application in the cluster, which node. You can have multiple nodes, but one of the nodes that's in the primary location, in the primary region. So that's how we're able to forward mutating functions and those requests over to the primary. But there's still another issue we have to address. And that is how replication works. Because when I say I want to perform a database modification, that's an RPC call, goes to the other server, and it is entirely possible and probably expected that the RPC call will return back before the replication in the database has completed. And if so really, ideally, we want to wait for database replication to complete. Otherwise, we have to write our application with the assumption that asynchronous data updates are happening, and that's like a normal thing. And that's like no longer a normal Phoenix app, because how do you develop that locally, right? How do you even know that it's working right? So really, the goal is we want to be able to have it serial so that we can easily reason about it. So we're just wanting to basically wait for that replication to complete. How do we do that? So Postgres has a feature called the write-ahead log, and we also call it the wall. But on their docs, they say, changes to data files, which is where tables and indexes reside, must be written only after those changes have been logged. That is, after log records describing the changes have been flushed to permanent storage. So those logs are written to disk first, and then they apply it to the database. They do that in case there's a crash, and they have a journal that they can recover from. But they're actually taking that same log, and that's what's getting shipped off to our replicas, and they're reapplying that same log. So we're already sending that data over. And if you want to know what a log sequence number looks like, you can see an example. That's just kind of for your information. And so what that means is when I insert a new record that creates a modification, a new log is created, then I can ask the database, what's the new log sequence number that includes that change? And then I have enough information to wait for it. So what I can do is I can do my RPC call, make the change in the database, grab the new LSN number, and return that with my RPC call. So now I have a log sequence number where I know the database records, the database changes that are required to include all my changes. And the replication process is happening asynchronously in the background. It's a separate process between the databases. Like, I have no insight to when that's going to happen, which is going to land first. And what's nice about these LSNs is they're comparable. So you're not saying, I'm waiting for this particular one that has all of these IDs and these records. It's not even at that level. So you're basically saying, I'm waiting for at least this log sequence number or greater, and I know my data will be there. So that's really cool. It's really easy to track then. So in order to do this, we need a stored procedure to help monitor in the database and be active in tracking it. So we created a little migration that's easy to add. You're welcome to look at the stored procedure. It's not really important to look at it here, but you just have to add the stored procedure to your application, and it's actively looking for changes. And the way that works, just roughly, we're going to talk about it. It's like your Elixir code talks to the database, makes a query to the database and says, execute the stored procedure. And inside the stored procedure, it does little loops and with pauses. But it's just checking to see, has the LSN changed? Has the LSN changed? Has the LSN changed? And as soon as it does, it says, oh, boom, here's an update. And I can stop. And if it hasn't changed after about 2 seconds, we stop so we don't have like these too long running of database queries. And we let that close out, and so then we can start and do another loop again. But that's just a separate process that's happening, one process per server. So it's not even every request. I have lots of edits coming at the server, and like lots of different users are using the same server and making edits. I'm not having lots of different things polling anything. So it's not inefficient like that. And like actually previous versions of this library didn't have the stored procedure, and it was Elixir polling the database. And that was presenting some problems because you're having to go across, application code across the network to the database and repeating that network transit time. So, well, we don't really want to do that, and this is actually faster, more efficient. But it lets us actively be monitoring for database changes when replication happens. So let's kind of walk through the process to make it a little more clear, right? So a con request or a live view process, but it's a process, right? Nothing happens in Elixir without a process being the one doing it. A process says, execute this function on the primary. And fly Postgres passes it on to the application running in the primary region. It makes the change in the database, and it passes back the LSN. So the RPC call returns with the LSN result, or the LSN, the log sequence number that has our changes, and the result of the call. And separately, replication is happening. And then the library is able to be polling the database. We know when the replication is completed that we care about, that this particular process cares about. So then we can say, hey, here's your result, and you're good to go. Your data is there. So this ends up resulting in making a distributed and asynchronous problem straightforward and synchronous. The main benefit being you can reason about it. And that's really the goal, right? And we're able to do all of that, like we saw the edits, how I was able to update, edit, and delete, and do all of that without changing any of my application code. And so it just happens automatically. So what happens when our normal code is inefficient and we're not close to our writable database? Because, I never write inefficient code. And I know you would never do it. But, it happens all the time, and a lot of it is because of the assumptions that are built into our mindset when we're writing our code, right? I'm not writing my code assuming that, when I'm writing my code, I'm assuming I have a writable database right next to my server, right? It's not written assuming that my database is far away. So things that were just fine when they're running close to the database, like in the primary, then they become not so great. And let's see what that looks like so we can spot it. All right, so over here, so yes, I'm still in Dallas. And here I'm going to, let's give a nice clean starting point. What this feature does is it lets me multiple select templates. And so like you can see, like this live view that's managing the selection, that's close to me, right? So it's like, just feels natural, feels like awesome. So now I say, well, I'm going to select 5 of these templates, and I want to create them. So I'm going to add slow, which is the default way if you don't change your code. And whoa, that was slow. My users are going to notice that. Well, let me see how bad that really is, right? So if I select all of them, what is that going to be like? Yeah, they're going to notice that. Yep. Yeah, there it goes. So, why is that so slow? So, here's the code. This is the code behind it, right? The code was perfectly logical when I wrote it. Does anyone spot the problem? Yes. Yes, it's these lines. I am doing the creates in a loop. And when I do the first create, it does the proxy over to the server, to the primary in France. And then it blocks this local process and waits for replication to complete before I go on and insert the second insert, right? It's like, that's not ideal. And then the second red line, that is after I've got all of my stuff inserted, I query it all back out using some sort ordering, and then I update each one of them to make their position permanent so it's a deterministic sort, right? So I'm revisiting the list twice, right? It's just, that's no good. But it was perfectly logical when I wrote it. So how do we fix this? So if we go back to that same code, if I pull that code out into a separate function, and so I just call this function add template locations, and the only thing I've changed, it's all the same code, the only thing I've changed is that I've changed the return type. and we'll talk about why I want to change the return type. But then the first function up here, that's my collapsed extracted function. And then what I've done next in my event is I'm going to explicitly RPC and wait. And because I've just extracted that code out into this other function that's just right next to it, I can just say, I want you to execute this module, the code lives in the same place, this function, and pass these arguments. But do that over in Paris. Do that function in Paris. What I love about this approach, though, is the code is all in the same place, right? I can still reason about this, as opposed to, oh, that lives in a separate background job, and that's in a separate place, right? Like, this is easy to understand and reason about. And then, all right, so like that's, so what we've basically done is chunked it. We've said, I only want to do one request over to Paris, do all of those operations, and then tell me when you're done with all of that. So why did I change the function result? And really it's because the data is always going to be sent by replication. So, I mean, we already know that's happening with the replication, so why also send it in a different form as the result of my function call? So the whole idea is, well, instead of returning the data in two different forms back from my call, I'm going to only send it once through replication, and then after that, it's the second line from the bottom, I'll just load my stuff, load my list of locations out after they were already sent over. So let's see what that looks like. So let's clean that up. So if I go and add all of them again, and I add fast, where I'm batching that all into one call, that's not bad, right? And it's like, as a user, I'm okay with that. Like, when I'm doing modifications, I kind of expect it to take some time. It's doing some work. But browsing around, instantaneous. But that's all happening on another continent. And if we want to see, here it is, we can watch the logs. It's like, this is some verbose logging. If we do this again, I can see, if I can highlight it right here, I can see the total time to do that whole list was 346 milliseconds. So not bad, right? Like, as far as the user experience, that's still good for like being able to modify stuff like that. So when do I want to use the explicit RPC and wait? If you're doing loops of modifications, if you're doing explicit transaction control, you might want it then. If you're using ecto multi, you might want to do it there. If you're doing, read, update, those kinds of things, that's when you probably want to wrap it up and have that happen over on the primary. So coming back to this standard backend with the SPA versus the multi-region live view with the replication stack, they both have to deal with long distances. The SPA approach requires custom data to serialize for transit. The replicated data is stored and accessed by JS. So we're still doing replication in both of them. Just on the live view side, we're letting replication be handled by Postgres. We're not having to transform the format of the data, not having to manage any code around the replication. And both approaches move the UI closer to the user. So the distance from the user to the user interface is short. And the SPA approach doesn't leverage any of Elixir's superpowers, which is the sad thing. I really want to cut those out. And so to be able to do that, I can do that with the live view approach, and I can do it without creating all those extra layers in my app. So if I can have that live view thing, what I get is it's an all Elixir solution. It uses clustering, it uses message passing, it uses ETS tables for fast in-memory caches. A single developer or a small team can develop and deploy this architecture more easily. They can maintain it more easily. And it plays to Elixir's strengths. So what I want you to take away from this is we can get team and project benefits of LiveView. We can serve a global user base with LiveView. We don't have to rewrite our application to do it. Postgres replication can be tracked and waited for. And the Fly Postgres library makes it easy to RPC database updates. And Fly makes multi-region easy and read replicas. And easy to, that's the other thing, is like, it was easy for me to experiment with what my users in Paris would feel like. I just put a server in Paris and I interact with it there. So I'm covering the same distance. I feel what they're feeling. The last thing is, I want you to know that you can do this, right? It doesn't require a dedicated ops team. You can keep your project simple, keep it easy to understand, easy to reason about. Like, that's it. Like, you can do this. So just a quick update on the library, Fly Postgres. In preparation for this, there's a PR that I have yet to merge, and then all those changes will be available. So like, if you look at it during this talk, it's not the latest one. But thank you very much for your time and attention. You can reach me online. There's my Twitter, Thinking Elixir Podcast, and any questions.
We have time maybe for 1 or 2 questions, so.
Is there, when you showed the slide about when to use RPC and wait, it seemed to be quite a comprehensive list. Like, would I just start defaulting to always using it? Is there a downside to doing that?
Well, you don't need it all the time. I would default to not use it ever explicitly until you feel something slow, and then you can look at it and say, oh, I'll wrap that up.
Yeah. The feel something slow is the part I worry about.
Well, yeah, you just deploy your app far away and play with it.
But why wouldn't I, though? Just always use it. What would be the harm?
There would be no harm. It's what it's doing for you underneath the hood.
Yeah. Because it's kind of happening anyway.
Yes, it's just, the idea is I want it to be as unobtrusive and uninvasive of your project as possible.
Understood.
It's like, if you wanted to rip out Fly Postgres, you could just rewrite that function call to do a local apply. And you could pull the library out.
As long as I'm comfortable committing to Fly Postgres and Fly I don't have to worry about that.
Right.
And then I could just sort of bake it in at a different layer.
Yep, absolutely.
Which I am on both counts. So good.
We had a person over here, I don't remember who, so if you're so kind to raise your hand again. A question there was? Okay, we'll go with the last one.
Yes, I'm just curious. So my understanding about how Fly works is you guys set up a WireGuard connection between the nodes, and so I'm assuming Fly RPC is sort of like a wrapper around Erlang RPC and like the node kind of library to set up the connection? Okay, cool.
Yeah, so it's using the Fly's IPv6 WireGuard private network to connect all of your nodes. Yeah, and then it's just using Erlang Beam interprocess communication.
Okay, if you have more questions, please feel free to reach out to Mark. Thank you, Mark.
Thank you.